Hello everyone, my name is Abu Rohan Shekh from Surendra Institute of Engineering and Management, Siliguri. So in this video, I will discuss about the design and analysis of 23rd story of RC building using ETAP software. Mm, Before starting the video, let me give you some basic introduction of this video. So myself, Abu Rohan Shekh from Siliguri, West Bengal, I am pursuing my bachelor degree in Surendra Institute of Engineering and Management in the Department of Civil Engineering. In this video, I will discuss about the design and analysis procedure of the third story of RC building using the most famous software, ETAS 2016. This video is basically created for the purpose of my project titled as Tall Building Design Project Assignment for Skyfi Labs online course. This video is not created for any commercial purpose, it is created for educational purpose only. So in this video, I have taken some references. So first of all, obviously the software ETAPS 2016. This is not mandatory to use the 2016 version of ETAPS. We can use the higher versions also. I have taken the reference from Indian Standard 456 2000, which is the practice code for plain and reinforced cement concrete. I have taken the references from Indian Standard of 875 1987 part 3, as I have applied the wind load on this structure. I have not used the seismic load on the structure, that's why I'm not using 1392 or another codes. So before starting this video, let me give you some roadmap. So basically, first of all, we understand the architectural plan, then we create the grid line. After that, we define the material body, then we define the section. After that, we define the load pattern. After that, we draw the section, then we assign the loads over the sections. After that, we run the analysis of the model. We design the model. Completion of successful run or successful analysis, we run the design the model, then we run the design checks. After that, we start the detailing, and at last it is completed and all done for the design and analysis of the structure. So first of all, let's understand the architectural plan. So we have a 23rd story building over here, and each story floor to floor height is 3 meter, and from story 1 to 8 the architectural plan will be something looks like this, and from story 9 to 14 it will be like this, and from in between the story 15 to 19 it will be like this, and in between the story 20 to 23 it will be like this. There is a constant dead load for every floor of this structure, but there is a varying live load from floor to floor. We can say from story 1 to 8 we can see the live load intensity is 5 kN per meter square. For story 9 to 14 we can see the live load intensity is 4.5 kN per meter square, and for story 15 to 19 it is 4 kN per meter square, and for 20 to 23 the live load intensity is 3.5 kN per meter square. And other loadings such like cladding, we use the auto draw cladding in the software. That's why we have to put the loads or cladding load manually. So we will use the cladding load as 0.2 kN per meter. Okay, fine. And we have section specifications available, such as beams having 3 dimensions: 500, 300, 500 into 300, 550 into 350, 600 into 400. We have 3 available sections for columns also: 500 by 500, 550 by 550, 600 by 600, and we have available slab thickness of 150 millimeter. So in this for beams and columns we will use the auto select property. So we will use the auto select property, so the ETAP software can predict the beams or column section which is suitable against the load, and for slab it is 150 millimeter. Fine. And in the material specification we have available materials such as M40 grade of concrete, high yield strength deformed bars of 500 grade, which will be used for main reinforcement of the column and beam sections. We have mild 250 grade of rebars, which will be used in the shear rebars or shear reinforcement. Hmm. So let's go to the software and see something about the structure. Okay, fine. So in this software we have at the first stage we have to define the grid lines. After that, defining the grid line, we have to define the material property. Over here you can see I have defined the M40 material, high yield strength deformed bars of 500 grade, mild to 50 grade. After that we have to define the section properties. Over here section properties, over here frame sections. In here we can you can see that beam of various sections I have added over here. After that I have created the beam auto select list. Then I have defined the various sections of our columns. After that I have created a column auto select list. And then after defining the material and section properties, I have defined the slab sections also. You can see the S150, which is the thickness of the slab. 150 is the millimeter is the thickness of the slab. After that I have defined the load patterns. I have also defined the load patterns. Over here you can see the dead loads having the self weight multiplier of 1. I have defined live load. I have already defined the wind load according to the Indian standard 875 1987. I have you can see over here that I have selected the value according to the location of the building. As VV I have selected its 33 terrain category. I have selected its 3 structure class. I have selected its C risk coefficient, that is K1 factor 1 and topography K3 factor 1. So wind speed is basically depends upon the zone which is found from the, we can see over here, we can which can be easily found from the Indian standard of 875 part 3 of 1987. From here we can see yes, a map is given of zoning on the page of 9, I think. Yes, on the page of 9 over here we can select our locations where the building is situated, and here's the some values also given. There's another list on the annexer 8 where the yes, on the annexer A, in the appendix A, the city towns list also given according to the Indian standard, and the basic wind speed which is also given against the city town. After that we can see the terrain category. I have selected as 3 terrain category. So it's also given it is also collected from the Indian standard. You can see a terrain category. Wait a while. Yes, over here we can see the terrain category. I have selected yes here 5.3.2.1 number of clause. Page number 8 we can see the category 3 of terrain, which is matches the matches the structures. That's why I just selected this attention C 3. I have selected structure as C, which is also from the standard. You can see over here. Yes, the various classes are given. Class A, class B, class C, and class C. So the class C, that means the structures and or their components such as the cladding, glazing, etc. having maximum dimension or the greatest horizontal or the vertical dimension is greater than 50 millimeter. In this case our building height is 69 meters. That's why I take this value as C. And for risk coefficient I just assumed that the mean probable design life of the structure in years is 50. That's why against 33 VV I have selected the value of 1.0 against K1, that is the risk factor. And for the topography factor, this is the K3. I assume that the slope is less than 3 degree, that's why I selected the value as 1. If the slope is not less than 3 degree or greater than 3 degree, then the value of K3, that is the topographical factor, is depends upon within the range of 1 to 1.63, I think. So in this case, the slope is less than 3 degrees, that's why I have selected the topographical factor as 1. Fine. After that, I have drawn these sections. You can see I have drawn these sections, the various floors. You can see the story number 18. Suppose like I want to see any stories, story number 18 or 10th story, suppose like, okay. In this case, I have selected I have drawn these sections using the property of beam auto select list and the column auto select list. After that, I have assigned the base as fixed. You can see the yes, I have assigned this base as fixed. You can also see the 3D model. We can see the cross sections, that is, it is a fixed base, and it is a fixed base. And after that, yes, after that I have assigned the dead load and various levels on the floors, and regarding supposed to see the loads, I can use over here as a dead load. So show frame dead loads, apply. Yes, I can see the dead load of cladding loads 0.2 kN per meter density at the external walls. If I shift it to the higher stories, I can see the loads also over the external walls. I can also see the shell loads. Suppose like I want to see the shell loads on the floor of story 12 against the dead load. I see the 2 kN of dead load is assigned on the shells. I can see the live load apply. I can see the live load of 4.5 kN per meter square. KN per meter square of live load is also assigned on the floors. I can see the wind load apply. I can see the wind load, that is, it is the coefficient 0.8. This is the minus 0.8. Over here minus 0.25 is here also, minus 0.8. This is the coefficient of wind pressure coefficient. We can see also over here wind pressure coefficient that I have assigned from the wind coefficient box. This is now the model is in locked situation. Yes, from assignment where the shell loads is given, from shell loads I can easily put the wind pressure coefficient over here. So if I have the wind pressure is collected from also the standard code. You can see over here on the page of yes, the page of 14, the table of 4, the 6.2.2.1 is given. Yes, on the table 4, the external pressure coefficient CP for walls and the rectangular flat buildings. Class number 0.21. Here I have selected this option. This sets as the 1.5, which is the height by width ratio, which is between 1.5 to 6. In this case, the building height is 69 meters and the width is 3 to 6, that is 18 meters. So 69 by 18 is something equal to approximately 3.8, which is in between the 1.5 to 6. That's why I have selected this. After that, there is a length by width ratio also, which is divided into two parts. So in this case, the length and width are similar in the both axes. That's why the length, yes, if the building plan is this, then the direction of wind is coming from the left hand side and it blows to the right hand side. So it is the windward direction, and it will this one and this one and this one will be the uh, leeward directions of the sides. So in this case the A portion is the windward direction, that's why in the windward directions I have selected 0 plus 0.8. I can ensure it in the model. Yes, in the windward direction I have selected it as 0.8, and the other portions I have selected 0.25 on the B portion, that means the back side of the building, and two sides I have selected the 0.8 negative value. So I can also ensure it from here. Yes, I have selected the negative 0.25 value from the back of the building, and in the adjacent side I have selected minus 0.8 for minus 0.8 for this value for this coefficient, wind pressure coefficient. After that, yes, everything is done over here from this code. After defining the every loads and after assigning the every load to the properties, I have just run this analysis. So we can run this analysis from here. We can run this analysis from just here also. We can set the load cases over here. We can set also the load cases. In this case the live load, dead load and wind load, both three loads are in active conditions, that's why three loads are in run actions. I can find from here the load combination also. Here the 8 load combination from Indian standard 456 is applicable for the dead load, live load and the wind load. I can see the algebraic combinations over here. The combo is equals to 1.5 the dead load. For the second one, the 1.5 dead plus 1.5 live, number 2 dead plus 1.2 live, 1.2 wind. Various combinations I have assigned over here. After that I have run this model. After running this model I have just go to the design sections, then I have select the Indian standard 456 code and against this design against these structures. After that I have just start the design check for the structures. After the, starting design check I have verify all members passed. After verify all members passed I can get the detailing of that structures. Even I can also get the value, wait a while, I can also get a shear force and bending moment and the stress value over on these structures. I can just select over here, this is the force for the structural component. For suppose like I want to see the shear 2 I can just apply over here. I can see the shear is 2. If I want to see the heat value of this beam, just right click over here. It will show me the detailed value of the structures, of this building element, RCC element, right? I can also use the show max tab or show scroll for values. I can just call this marker or just put here I want to value from 3 meter of span. Just put here over here 3 and just hit the enter button. I can get the value for shear value of minus 1.2783 kilonewton. I can get the moment, I can get the deflection from here also. I can set the load over the load cases, about dead load, live load, wind load. I can use the load combinations. Here the 8 combinations of loads are given. I can use the model cases also. Everything I can do from here, or I can check the values, internal values, internal force values of the structures. I can also see the value for columns. I can see the shear values like minus 0.1231 kilonewton at a distance of 2.5 meter. I can see the moment value over here. I can see the equivalent loads over here. So against, I can see the live load. Against live load, it gives the value of minus 15.6455, something like. I can also show the wind values. Here the wind value is not in axial direction, that's why there is no wind, there is no values, or there is no forces against wind load. After that, just press the here done button. Okay, now I suppose want to see the stresses on the slabs. So just click over here and just select the component, and I can over here I can also see I can choose the dead load, live load, wind load. I can also use combinations over here. The 8 combination is also given. I can use mode, the component. I can set F1, F2, the F maximum, whatever. I just select everything. I put the apply button, and it will give me the value for shells. Yes, I can show the values for shell, and here is the indicator which indicates the magnitude of the stresses or forces. Okay, now close it. Now suppose I want to see the detailing, right? I want to see the detailing portions or design detailing portions. So just go to the detailing tab where I have the drawing sheets available. Before detailing, I have just here I have just start detailing. I run the detailing. After that, I get this all these sheets. After here I can just double click on any general nodes. Suppose like a concrete beam, just double click over here. You can see the cross-sectional elevation, the cross-sectional plan of the beam for the detailing. You can see the zoom here. I can see the confining zone. I can see the major confining zone. I can see the confinement bars, which is placed at a lesser center to center distance for the confining zone. Here the shear stirrups or the shear reinforcement is placed at a maximum distance. And I can also see here the plan of the cross-sectional plan of this beam section C. I can see the another sections, suppose like A, suppose like C. Just double click over here. I can see the various cross section. So here is another cross sections of that beam. So beam section B, here beam section A. I can see. Suppose like I want to see my floating plans. On floor framing plan story 19, I can double click. You can see the RC detailing for the floor planning over here. There I can suppose want to see the column schedules. So double click over here. I can see the column schedules. Here the story is mentioned. Here the column tag is mentioned. Here the column size, section, reinforcement details. The reinforcement details was also given. The tie zone is given. Tie zone A, B, C is also given for the. This is for the CC 110 columns. I can see the results for various columns also, and I can also see the concrete column layout over here. It is also provided. So column layout is also given. The center to center distance is mentioned over here. I can see. So I can also generate the reports from here. I can generate reports from this. Double click on the project report. It will show you the project report of this structure. To generate the project report, it takes some time to generate. It stays on the configuration of the computer, PC, or desktop. So wait a while until the file is not generated. Wait a while.